there are fairly many meetings going on. Seminar meeting is being going on, so that's the notification meeting. All right. So this is the contents what we are trying to discuss. Hope you all can see this, right? So this is the one last module, and you might have seen the circulars, right? It is from the university. So first some exams will be scheduled, are scheduled. 8 some exams are scheduled yet. All right. So they are given some inputs for them. So based on that, you can understand and follow up, right? Okay. So let us discuss this module contents. So this is all about message passing. How do the operating system will pass on the message? Okay, and what all the technicalities inside that? So this what is that syllabus contents what we discussed earlier, right? Any doubt in this? Does anyone have any doubt in that? You can raise your hand. We can see some conversations. Okay, all right. So let us begin with. So let us begin with the first slide. So for this, you need to refer chapter number 9. Okay. So please note down these contents. So it's what introduction of message passing, how message passing will work and all that, and how do we implement this? How do we actually implement this message passing? And further, mailboxes. How when you are trying to send a file, right? You have a file with you. You'll try to send a file and you try to share it with someone. But what kind of mailboxes we're going to use? Let us see. And deadlocks is an actual interesting concept of operating system. Deadlocks. So it's very simple concept actually. Deadlocks mean like whenever you travel for a 4 road junction, you have a 4 road junction, you travel for a 4 road junction, and the traffic gets struck up completely. Correct? You might observe that, which means none of the vehicle can move. So that's called a deadlock condition. Like you move one vehicle, other vehicle will come and struck it up. So it's like a situation where you cannot able to move 1 inch from there on, right? Those kind of situations are called as deadlocks, which means there are n number of processes working on parallelly in the operating system. If one process is going to handle one corresponding event, and then the other process is going to interrupt this, it's keep on disturbing the one to one, then the process can be served. Okay, so it becomes like that. That's called as a deadlock condition. So in that case of deadlock, how do we allocate the resources? If it's completely stuck up, let us say I am taking the class in the team here, and if the team has got stuck up completely, the laptop has got stuck up, or I cannot able to change the next slide, right? In that case, how do I allocate the resources for it? Even I am trying to use escape, it's not working. Let us say, for example, and I'm trying to use the mouse cursor, is not working. So in this case, how actually you allocate the resources for it? Okay, that is allocation of resources. The next is handling the deadlock. If you got deadlock provided, how do you handle it? Which means how to tackle it. Okay, and how to find whether we have a deadlock or not. The detection algorithms we have, and how do we prevent it? So this complete module will talk about message passing and deadlocks. Okay, in message passing, there are 3 contents: message passing, overview, and mailboxes. 3 concepts, that's all. Introduction part, next deadlock in resource allocation, handling deadlocks, deadlock detection, deadlock prevention, and all that. Okay, so let us go into the contents. So overview, let us see. So check this overview of any idea you're going to get from this overview. So look at this, read this, let us discuss on it. So any idea you got, you please let me know. So please read that. So that's all absolutely what the contents what I have shown absolutely are there in this syllabus. Okay, overview of message passing, implementation, message passing, mailboxes, deadlocks, resource allocation, handling deadlocks, deadlock detection algorithm, right? Detection, deadlock prevention. So all that absolutely these are the contents. Yeah, please go to the first one. The very first topic of module 5. Heading of module 5 is message passing and deadlocks. So you need to refer two chapters. So in 10th and 11th chapter as per the prescribed textbook, second edition, and you need to refer, I think, 9th and 8th chapter for the first edition textbook, what we have as PDF file. Okay. First one, today let us discuss on overview of message passing and followed by implementing the message passing. Let us understand this message passing. What is it? So please go through this message passing. What does that mean, message passing? So one process has to interact with other process. Like before, what we did, like we have trained only one model. Like we have trained you, how you should behave, how you should talk like that. And now you are going to communicate with the other person, right? So like that, we have a process with us, and we have a process with us, and that process has to communicate to others. Okay, it's like one way in which the process interact with other process. Okay, it's very simple. Like you try to understand here. Now any website you try to open, there will be an automatic shoot up robotic messaging. You observe that? Hello, have you observed that? Okay, instead of calling to the customer care, you are trying to interact with the person directly. You just type a message, you put a message. Okay, that's called a thread. Let us say you are the uh, producer of it. You are trying to do it, right? Get the message. You get the message back. You say hi, it will say hi. Like how you play with Siri and Alexa, right? So that kind of thing you can do with message passing when you try to. Any questions? Any cross questions you have? No? Yeah, all right. So that's what message passing here means. I'll send a message, you need to receive it. Like simple context, when you try to message someone in mobile phone, or you send it through WhatsApp, or you say mail, so whatever it is, you are a process, you are communicating to other process. You see the example here, 9.1 diagram. There are two processes, process PI and PJ. I is a sender, J is a receiver. I is having a message which has to be sent to J. Okay. Now we are trying to fix that. You see that cleverly how they have written that send to PJ. We have to send to J. Okay. What you have to send is being kept in that HTML parenthesis message. You have to send, not receive. You have to send. Whom you have to send is very person or the process whom you have to send is given there, PJ. And the message what you have sent is given there. So send, whom you have to send, what message you have to send. That's what the context they are given for the sending part. Whereas in case of receiving part, process PJ has to receive. From whom it has to receive? From process PJ. Okay, what it has to receive? The content from the message area. That's what is mentioned there. All right, is that clear? Now, you may tell, sir, whether these two processes will exist in same computer or different computer. So it may exist in the same computer or different computer. We cannot say, right? It can be same or it can be different. Okay, so it can be same computer or it can be different computer. Next, uses of message passing. Why we use this? What's the benefit of using message passing? So it's like just like client and server type of setup. Client will communicate to server, server will reply back. So client server type of technology, it is message passing. Okay, and this is the backbone for higher level computing protocols. Any higher level computing protocols what you have in operating system. Okay, so this is the background. So what are the higher level protocols? What are the higher level protocols in operating system? So it can be file transfer protocol, It can be TFTP, NFS, SMTP, LPD, Xwindow. So all these are Telnet. There are different number of protocols what we have. All these are higher level protocols. So for all of them, the message passing what we are seeing now is the backbone. Is that clear? So that's it from this slide, and it can be parallel and distributed programs. So let us say this message has to be sent parallel to n number of processes. It can send and it can distribute the things. So it's a parallel and distributed program. So these are the users or the overview of the message passing. All right. So let us see continue that what is this message passing. Okay. Two important issues in message passing. What is that? Naming of process. How to name the process is one of the issue, and delivering the message is one issue. How do you name first thing, and how do you deliver it second thing? So these are the two issues what you have in message passing. Okay, how to overcome this issues? What are the two issues we have? Message based computing, like sending or receiving and all that. Okay, and what is that? Naming of process and delivering of message. What is naming of process? Names may be explicitly indicated or reduced by the kernel in some manager. So you may give the name for the process, or it is being taken care by the kernel manager. Anyway, so these are the two problems what we have. How do we name it? Right. So even like sometimes you try to see when you want to send a message to someone in WhatsApp, it may not take sometimes. You have to save the contact and then message. So the naming convention is important. So the challenge there. Have you tried this? Anyone can acknowledge back? Is that possible to send without saving the contact? Yes, maybe sometimes. No, yes, no. Any answer? Any one of you? So that's the naming convention challenge we have. If you try to use an example of WhatsApp, like if you want to share any message to anyone, you need to name that contact, right? Then you can able to do it. And delivery of message. So that's what. These are the two things what we enter in message passing. When you try to deliver that, it may take some time to load it. Right? Whether the sender should be blocked until delivery. Right? Until you deliver that message to them completely, it will not be received. Like message typing, it will come. It will not show what is being typed. But that technology also came now. That challenge is overcome through the other messaging app, Telegram. Whatever you are typing in that, till now, whatever you are typed, it will be visible. Let us say you want to type, hi, how are you? How are you doing? So, hi, how are you? You have typed. That much will be visible. What are you doing? If you are typing WH, that will be visible for them. Whatever you are typing, pin to pin will be visible for them. Right. So, leaving that context here, coming to the operating system, whether the sender should be blocked until delivery. This is a challenge again. This has to be addressed. And what the order in which messaging are to be delivered. Let us say you have forwarded some 10 messages to the other person. Like you take example of WhatsApp only. Which one will go first? Can you say? You want to send 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers you want to send. You have forwarded those numbers. The message is what? 1 is a message, 2 is a message, 3 is a message, like that up to 10 messages you have sent. So it may come in same order, it may not come in same order. You have to experience that, right? You're forwarding 10 messages. First message you want to try to forward may have more MB, it may come at last. Or last message having less MB may come at first. Okay, so these were the challenges what you have in message passing. And what is the third challenge what we have in delivery of messages? How exceptional conditions are handled. There is an exception. How do you handle it? Exceptions can be what? It can be, let us say, message has to be passed on. The other side, there is no proper reception. How do you handle it? It got blocked. It is not sent and it is not received. Now, what kind of message you're going to give to the next set? Whether it's been received or it's been not received. Whether it's been sent or not sent. So these challenges what we have has to be addressed. So this is the overview of the message passing. Okay. And how do we name it? Let us say naming convention. It can be named directly or indirectly. Right? In case of direct naming, sender and the receiver processes mention each other name. Directly, it will ask what is sender name, what is receiver name. It will be given directly. Say, for example, send the destination process, the message length, the message address. So that what will be there in the sender. Whereas in case of receive, source process, see that's what the source process and destination process. Let us say, for example, they are like a name, right? So this is the way what they are trying to communicate, sending and receiving. Okay, and again there are the namings can be again symmetric or asymmetric. In case of symmetric naming, the sender and receiver, the sender as well as receiver will process and specify each other name. Symmetric. So it will happen by itself defaultly from sender side and receiver side. It will exchange the information. It's done. Clear. Asymmetric means what? This the receiver does not name the process from which it wishes to receive a message. It will not say from which process I have to receive the message. It will not say. That kind of thing is called asymmetric. The sender and receiver, both of them know that it is being done. That is symmetric. Let us say, for example, you have a class now at 11 o'clock, right? You are informing your friend like, yeah, at 11 o'clock, please inform me, I have a class. Or you are telling your sister or your brother, at 11 o'clock, I have a class, please inform me. So you have told that message to them. So they also know that they should say to you, correct? Now what happened now? Both of you know each other. Whom you have to send, whom you have to receive from. Both of the clear. That's symmetric naming. Asymmetric naming is what you just message randomly in some group that you please help me. But whom you want the help from, you're not messaged. Or whom you want to take the help from, you're not discussed. In that case, what will happen? Anyone may help to you, but you don't know who is going to help you. Right? Like this, you have a message to be received. Who is going to send the message if you know? That is symmetric naming. And who is going to send the message you don't know, but still you are receiving it? That's asymmetric naming. Okay. And sometimes you may put up the settings. Who like and you again take your example of your WhatsApp. If the profile pic has to be viewed by everyone, or only in your contacts, or none of them. Correct? Only in your contacts will receive your status update. That's something like that. Okay. And next, asymmetric naming, receiver does not name process for which it wishes to receive a message. And the kernel gives it a message sent to it by some process. Kernel is going to take care of that, but not by the receiver. That's it in the direct case. So what is that now? Direct naming, contributed direct naming. Direct naming, it is in case of what? Direct naming. Sorry. Direct naming is being done. Yeah, direct naming is being done in symmetric manner or asymmetric manner. You just hold on for 1 minute. I will just resume it. I'm on. It was there. Just 1 minute. I'll be back. All right. Thank you for waiting. Yeah. So where we are in case of this, We are at direct and indirect naming. So we have seen the case in of direct naming. So direct naming can be of symmetric or asymmetric, right? And similarly, indirect naming. So you can see indirect naming. So in indirect naming, process do not mention each other name. In indirect naming, what is happening? The process do not mention each other naming. What does it mean? In case of asymmetric, the receiver does not name process, but sender have the name. In case of indirect naming, the sender does not know who is the receiver, and receiver does not. Okay, so these are the things what we have in case of direct as well as in case of indirect naming, right? So blocking and non-blocking sends. There are two types of sending messages. You send a message to someone, or you send a message to other process. Now, which is unblocked. That way is different, and other one is blocking. What will happen when you send a message in your WhatsApp to someone? They blocked you. You don't know that the message is being received by them, but you feel like it is being sent from your side. From your side, it is sent, but they are not able to receive it. They have blocked you, right? So that convention, let us try to understand here the context of operating system. So a blocking send blocks sender process until message is delivered to the destination process. Okay. Until you deliver the complete packet there, you cannot able to see the message. Even though you feel like something is being sent, if you download that, it will keep loading, right? So that kind of context here, a blocking send blocks sender process until message is delivered to destination process. So again, this one can be synchronous or asynchronous, let us say. In case of synchronous message passing, so this is type of synchronous, not asynchronous. This type of blocking is kind of synchronous message passing. Okay, and this will simplify the design of concurrent process. So because of this, the process gets simplified. It's very simple, right? We do not know what is being sent until we receive completely. So that's the concept of synchronous. And what in case of non-blocking? What in case of non-blocking? The non-blocking send call permits sender to continue its operation after second call. The non-blocking send call permits sender to continue its operation after send call. After send is being done, then it will operate. It's an asynchronous message passing. So based on this parameter, we can able to enhance the concurrency. Enhance the concurrency between the sender and user. We can enhance the concurrency. Okay. Where in case of blocking, as well as in case of non-blocking, what we are trying to do, we are trying to receive. Okay, the receiver is typically blocked. So the sender may be active in some cases, but the receiver is completely blocked. Not completely, let us say typically blocked. Okay. And the kernel which will perform the message buffering pending delivery. So it will show something buffering, which means the delivery is been pending. The message delivery is pending. The buffer, it will maintain that through a kernel. That's what about your blocking and non-blocking. Next, there are some conditions which are exceptional conditions in the message passing. What is this exceptional conditions? So we need to handle the message. If you want to handle the message, you need to handle the exceptions also. Exceptions means like something like interrupts. Okay. So send and receive are two parameters we have. In that we have flags and status area. What does the flags do? Flags indicate how exceptions should be handled. What does flags do? Flags indicate how exceptions should be handled. Let us say you might experience in your programming languages, or you might experience the zero flag, carry flag, all right, and equal flag, non-equal flag. Like that, there are various number of flags what you have. Let us say, for example, carry flag. So when you try to add two numbers, you got a carry flag will set. So like that, here in operating system also, whether the receiver is ready to receive the message, you do not. Right? Based on that flag condition, you can able to send or you cannot able to hold. So that flags will help us in deciding whether it's active or it's not active. Correct? This what will happen for you, right? You are trying to send someone some amount through Google Pay. You are trying to do it transaction. Correct? You want to make a payment of a glossary guide. So if he is there in Google Pay, you can able to send. He is not there in Google Pay. Then you get the flag is 0. Then that corresponding contact, whatever you are trying to send the money, what will happen to you? It will not activate the process. The flag is 0. He installs the app and he get into it. The flag will become 1. Then he can able to continue. That's the flag's role. And status area. Status area means what? Even you see sometimes in online messaging, if you are active or inactive, or you are blocked, or you are doing available, busy, all that is your status area. This is for storing code concerning outcome. Storing the code. Okay, this is about the storing the code status area. Now, let us see some 5 conditions here. First condition. To understand this, what is this blocking and what is the exceptional message passing, let us see the conditions. First condition is what? The destination process mentioned in send does not, as you've seen, right? You're trying to make a transaction to one person with the number 1, 2, 3, 4, 5, 6, 7, 8, 9. That never doesn't exist. Now it's an exception condition. Now what to do? How do you handle that? That's a problem. Next, the second kind of exception example. Source process does not exist. Source itself is not there. Like I told you, like you will get a message from what to say, a message from ABC. You'll get a message. Then how do you get a message? Right? Source process does not exist. The receiver is waiting to get the message, but source is not existing because that is busy in some other activity that is not ready. So that's by symmetric naming we can say that. Third is send cannot be processed. You have sender, you have receiver. Send cannot be processed. Like you both of you are available in Google Pay, for example. You want to make a transaction. You don't have internet. The data pack is got empty. You cannot able to give send. You'll be able to send it. So send cannot be processed. So this is again an exceptional condition. An exception. Okay. First case, destination problem. Second case, source problem. Third case, send problem. Fourth case, no message exists for a process when it makes receive. You have to send a message. You have sent it, but nothing was there in that. You might have sent a message, a blank message you might have sent, or a simple dot was there, something like that. No message exists for a process when it makes a receive. It has received. Let us say, for example, you received a letter. You open the letter, nothing is there. A4 sheet, white sheet. What is that meaning? So this is also an exception, right? And next, fifth one. A set of processes become deadlocked when one is blocked on a receive. Whenever you are trying to receive it, it got blocked. So that became deadlock. Okay, that's the fifth exception. So these were the 5 different kinds of exceptions in your message passing. Okay, so that's the first concept. Let us quickly recap that first concept. If you look at this one here, so introduction, first topic in your 5th module is overview of message passing. In that, what all things we have overviewed, recap it. So we have 2 processes, process PI and PJ. PI is sender, PJ is receiver. So PI has a message to send to PJ. So this is the context what we have. So this is similar to client server based, and this is the backbone for all the high level protocols, and it can be worked in parallel and can be worked in synchronized manner. And next you have a naming conventions. So naming conventions is a problem. We have seen how the problem will happen in naming of process and delivery of messages. So these are the 2 challenges what we have. So naming. So naming again we have a problem in the direct and indirect naming. So we have seen direct is a symmetric and asymmetric form. Indirect between send and receive. So that's about the naming. If you see this one here, so there are 2 challenges, message passing issues, naming of process, delivery of message. So we are trying to see direct and indirect naming. So blocking and non-blocking sends. So blocking can be synchronous or asynchronous. Again, naming also can be symmetric or asymmetric. Blocking can be synchronous or asynchronous. So that's what we have seen. Exceptions of message. There are 5 exceptions. The destination doesn't exist. Source doesn't exist. Second one, send cannot be processed. There is no message exists. Fourth one, and fifth one is what? Deadlock when one is blocked on a receive. So these are the 5 different exceptions. That's the overview of the message passing. Is that clear? Any questions? Any discussions? Please welcome. Okay. So we'll see the overview of this implementation and we'll discuss much more detail in the next class. Let us see the implementation overview. Let us run through the slides. So this is the diagram, implementation diagram. Delivery of inter-process messages. Okay. Code here given. What is that algorithm has been given? How to implement that? That's a very simple concept. We can discuss now itself if you are interested, or we can discuss in the next class. We have enough time to discuss. If you have any questions, you please ask, or else we'll begin with implementation of message passing. So that's what till now what we have seen is the overview of message passing. If you have any queries, please put on. Please unmute yourself and we can discuss, any one of you. So let us talk to someone today. Any one of you, Annapurna, you're on hold. Punashri, you're on hold. Any questions from your side? Kanta Pradeep, Jyoti, Bhumika, Chidambar. Hriday. That's a problem or what? All right. So let us have an overview of this quickly and we'll discuss in detail about this in the next year, right? So implementing message passing. So implementing message passing, we have some IMCP. IMCP means what? Inter-process message control block. IMCP means what? Inter-process message control block. So using this inter-process message control block, IMCP, we have a sender, we have a destination, we have message length, we have message text, and IMCP pointer. So very simple block it is. What is that? It consists of what all things it consists of? Sender process, destination process, the length of message, and the text of our address of what message has to be, and then pointer of IMCP. IMCP means what? Inter process message control block. MCB is very simple, message control block. We are clear. I stands for inter process message control block. Okay. Now the next diagram 9.4, you look at list of IMCPs for blocking sends. That for blocking send we use this. Next is symmetric naming. In that A part is symmetric naming, B part is symmetric naming. Symmetric naming, you see what is happening here. Same diagram. Can you spot out the differences? The difference between the 9.4A and B diagram. Symmetric naming, asymmetric naming. Any one of you can find out the differences. So this was the list of, let us list of IMCBs. IMCBs means what? Inter process message control block. So the gray colored one, what all there are IM. There, because IMCB pointer is there, right? Pointer is starting to the sender process. So from there it will send to next one. From there it will send to next one. So like that it keeps sending from one block to other block. Can you say what is that? That's what you play the game, right? Find the differences between the two diagrams or two cartoons. Correct. Game you play, then you can spot out the difference easily between symmetric and asymmetric naming. What's the difference between the two diagrams, 9.4a and b? Anyone of you are good enough to spot out the differences? You're welcome. Is it done? Have you spotted the differences? Only difference was there at what place? You see that at the starting address, so PI to PJ, it is there, but whereas here only PI is there. PI to PK is there, it is only PJ is there. PI to PAJ is there, only PJ is there. So like that, you see the sender and receiver both are there. Okay, that is symmetric. If only one was there, it's asymmetric. That's very simple, right? Let's go for the next one. So delivery of inter-process messages. So what does it mean? The delivery of inter-process messages. So what does it mean? Will you go through this and come back in the next class? A and B we have. A is sender at send part and B is at receive side. One is at sending side, other one is receive side. All right. Okay, please look at this and come back. Let us have a discussion on this in detail. That's the end of this concept. Which one? Implementing message passing. How do we implement this one, right? After that, next one is mailboxes. We see half of the module is done. Very simple and easy module. Okay. Once you complete this mailbox, how to use mailbox and all, one example, still a long way to go. And later followed by deadlocks we have. So from here, the other section will start. Right? It's too early to discuss now. Let us focus one by one, take it one by one. As of now, for today, it is overview of message passing. Only one concept per day today. Overview of message passing. Yes. Then so next is implementation part. We'll look at next class. All right. That's it from my side from today. For today. So any queries and any questions in particular, you can type it in chat box or you can unmute yourself and discuss. So if there are no questions, thank you all. See you in the next class.